Hey folks, I'm Jason Rohrer. Over the past 20 or so years, I've made a bunch of different games, including most recently 1 Hour, 1 Life, going back before that, The Castle Doctrine, Chords of Minuet, going way back, Passage, Sleep is Death. These days I'm working on a new game called Chessamphetamine, and I'm developing a brand new engine for it, and this video is a tech demo of some of the features of that engine. But before I show those, I want to provide a little bit of motivation for why I decided to build this new engine and what it does, based on showing some of the features of the 1 Hour, 1 Life engine and some of its drawbacks. One of the cool features of the 1 Hour, 1 Life engine is the ability to record and play back games. Well, let's say I have this local server running here for 1 Hour, 1 Life. I'm going to launch the client. As I move the mouse around and type things, and as there's network activity and so on, all those events that change the state of the game are being recorded into a text file, and that text file can be played back later to play those events back. So right now, as I move my mouse around, you see that everything I do and type, well, you'll see it later when I play it back, but it's being recorded. I'm going to log in. Now that I'm logging in and connecting to the server, all this network traffic between me and the server is being recorded. Go down here. Let's pick up this knife, come back up, and slaughter a sheep, and then set the knife down. Okay, so let's quit the game, and now when 1 Hour in Life starts up again, this cool feature happens. So you can see the playback is happening. As I was moving the mouse around during loading, you can see that's being played back. So it's actually just playing back the events. All the loading, all the drawing, the animations, and all that stuff just happens in the game engine as if those events were being played back again. So I'm going to click here on the email field in a second, start typing something like I did before, delete it, and then go ahead and log in. So at this point, all this network traffic is coming from the recording. It's not coming from the server itself. You can see me clicking around. Server is serving the fact that the sheep moved. Server is answering the question about whether I can pick up the knife. If I go ahead and quit and stop the recording by hitting escape, though, watch what happens. Connection's lost. Why is that? Well, the network data stream that was in the recording is over. You cannot pick up and carry on from that point in the game because there's no connection to a real server anymore. So this is one of the weaknesses, along with one big weakness is when a user sends you like an hour-long recording, you got to watch through the entire thing because really all those events have to be simulated to actually see the game state evolve to the point where they ran into the bug. As cool as this was to see like this ghost moving around and controlling the game, in very rare circumstances it helped me find a show-stopping bug, but most of the time I didn't end up using it because it was just too cumbersome and too slow to like play back this long recording. But the other thing about the 1 Hour in Life engine is, let's say, I want to make a change to the content. Right, I want to change those sheep that are walking around. I want to make them black. So let's open the editor up. The editor's loading up, and it only takes about 10 to 15 seconds, which is pretty quick for a game that's. This is like tens of thousands of files. There's like it's close to 5,000 sprites, all these animations, and all these things that are being loaded, and the editor has access to all of them now. Just page through every single. There's thousands and thousands of objects in the game, and a quick list here. There he is. Okay, so let's pick like his coat and like pick a new value for it that kind of darkens him up, not make him fully black because you can't see his swirls, like make him just a dark sheep like that. And then I can copy that color and page through all his other white parts and paste that color on them. So the editor's pretty quick. That part's not too bad. And his hair on the top of his head. Now we replace him, and there he is in the list as a black sheep. Now, of course, I might want to see him in the game, test him, see that he's working properly. So now next step is to come back here, kill the running server, reload the server so that it has that black sheep loaded, reload the client so that it can load that new content and log into the server and connect and walk around with those new sheep. So this 10 to 15 seconds of loading time doesn't seem like much, but when you're in the throes of content development and tweaking and testing over and over again, you spend a lot of time just sitting here waiting for these progress bars to go by. There's just this downtime that interrupts flow and so on. So you see, oh, hey, the sheep worked, and they're there. But let's say I'm actually testing the gameplay around the sheep, right? Like making sure the transitions work with the new black sheep, and I go down here to get the knife, come up here, walk all the way down there, get the knife, walk up here, missed one, there, slaughter, oh, no, there's a bug. Right, the sheep turns white when he's killed. So I need to go in there, go back to the editor, fix it, come back here and test it to make sure that it actually worked. Walk down and get the knife again and again. And that recording system that I have won't help me with that. Right, it's not like I can like jump to that spot where I'm about to slaughter the sheep and test it again because the recording just ends and I can't continue on I'm not connected to the server anymore, and so on. So these are the things that I really felt like I wanted. I was like suffering from over 10 years of development and making thousands and thousands of objects and testing them all on the system. Sometime toward the end of my 1 hour in life development, one thing that I saw that was really inspiring to me was this video that Tomorrow Corporation put out showing a demonstration of their engine. Tomorrow Corporation is the company that made, back in the day, World of Goo, Little Inferno, Human Resource Machine, and a bunch of other games that are really, really cool, really high polish and well engineered, they feel like. In this video, they demonstrate how they actually, over 10 years, have built their own programming language, their own compiler, their own debugger, which has full like memory recording and rewind ability, including rewinding the code base. As you edit the code, you can actually rewind a different point in the code and so on and play that back from there, along with hot asset reloading. So in this demo, they added some sprites while the game is playing and they instantly load in. Very, very, very impressive stuff. It's like the dream tool for me as a programmer watching something like this. A lot of people are skeptical that this really works. I think from what I've seen and the detail that they go into this video that it probably does actually really work. So it's absolutely amazing. I mean, these guys are incredible. But it's also, for me, felt really out of reach. Like, oh, they spent 10 years doing this. They created their own programming language and all these tools. I don't have 10 years to spend on my own compiler, programming language, debugger, and so on. I need to work on my next game and get it out the door. So if I want to do this, like if I want to actually get to the point where I'm hot reloading code, what programming language could possibly work for that? What can be compiled fast enough for hot reloading? There's lots of different compiler kind of shootouts, but one of them here on this alepex.li wiki tests a bunch of different compilers for a bunch of different languages and measures them for compiling lines of code per second. And one thing stands out above all the rest, which is the plain old C programming language as compiled by TCC, which compiles 125,000 lines of code per second. This is like 350 times faster than Rust. Even Go and Pascal, which are very fast to compile. TCC and the C programming language is 2.8 times faster than Go or Pascal to compile. So if I come back over to Chessamphetamine over here, and we do a CLOC, which counts the line of code, and look at star.c and star.h in my game folder here. So far, on this game that I'm working on, I have 24,000 lines of code. So using the TCC compiler, I have this little script that I call fast Linux compile. But if I do this, wow, it went by in the blink of an eye. That's compiling the entire code base, not conditional compilation, not incremental compilation, compiling the entire code base from scratch. Let's see how fast that was. 126 milliseconds. Sometimes it can be a little faster than that. 119 milliseconds. There's actually, because I have Audacity running in the background recording this, for some reason Audacity is using a lot of CPU. Normally it's around 98 milliseconds to compile that many lines of code. So that's basically the blink of an eye, fast enough for hot reloading without having to have any kind of built-in editor or anything, just kind of hot reloading on the command line. But before we get there, let's look at just hot reloading of assets, which is a little simpler, right? It's just, the engine is paying attention to the modification times of files, and when one changes, it reloads it, puts it back into the sprite memory and so on inside the engine. Let's do a fresh run here and look at a couple of things that I can change in real time in the assets. So getting started here, looking at this this rook here, which is supposed to have these like laser emitters on it because it's a special piece. Well, actually, let me first of all explain that Chessamphetamine, because you're going to see me kind of playing it out here, is chess auto brawler, so or auto battler. So the chess game, after you pick your pieces and place your pieces, the game kind of plays out, and you see the engine kind of playing against itself, making decisions. So if I hold down the spin button here, these pieces all start moving. That's not a recording of a game. That's actually just the auto brawler playing out. But let's say I don't like the way this thing looks. Come over here into ASprite and say, actually, that little laser emitter is a little too high. Let's move it down and line it up with that wire and just hit save. And you can see that it instantly jumps into place here. Okay, so that's actually really useful, especially when you're doing things like, tweaking slight positions of things and how things line up, to be able to like tweak it one pixel at a time and see it happen. The other thing I really love, at least in this version of Debian, is that you can zoom in on your stuff, and you can actually see, like if I raise that up, you can actually zoom in and see I'm holding Alt and slider, Alt and mouse scroll button, and you can see you can actually count the pixels in here, like while the game's playing, and say actually that needs to move down by 1 pixel to line up with that wire. So anyway, that works really well. But this works for all kinds of things, like even inside the engine's UI. Let's look at like, oh, there's a typo here, right? So not just the graphical assets, but any text assets, right? So this is the language translation file. So if I go ahead and save this, the translation updates instantly. If I come in to like the font and say, actually there's 2 pixels between each character, let's put it up to 20. It's gonna be crazy, but whoa, yeah. So let's put it up to 4 because that looks too crazy. So that kerning and everything is recomputed in real time as this file changes. We can go ahead and just, put gook on one of the buttons, and that just automatically updates. Okay, and then if we come into Sprite again and look at this Latin font, and I was thinking, hey, wouldn't it be cool if these E's looked like more like kind of 80s retro cyber kind of thing. Oops, let's get out of this input. So let's say the E has this crazy swirl that comes down and kind of like a thing that hangs under the other letters, maybe. It's kind of dumb, but let's just see how it looks. And maybe we shorten this off a little bit so it'll fit better. Okay, that looks cool. Save it, and all the fonts update and rekern and so on, so you can see the kerning handled like that E going under the other letters and so on. Of course, I don't really like that. It was just a demonstration, but let's just undo it in Sprite and get it back to normal, and it instantly jumps back to normal. I mean, you can also go and edit any of the GUI components that are Sprite based, like this thing. Let's put like green X across it or something like this. Save it, and it instantly jumps to that thing. So really useful, especially when I was tweaking the end caps for these and trying to get them lined up and so on to get that all working. Okay, so that's great for static assets. They're just sitting there on the screen, having them hot reload as you tweak them and move them around. But what happens when you have some kind of dynamic asset? So if I continue playing through this auto brawl by holding down the spin button, we'll eventually see a visual glitch that happens really quickly here. And there it is. Okay, so that laser went by and had some gaps and other things in it. We're gonna see another one there. Okay, there it is. And it's okay, I want to go and here's the laser sprite that I need to edit here to fix that, to get those gaps to go away. But it went by so fast, I can't really hot reload that and see it happening. And so one thing that helps with this, right, is even if I wanted to, we're back to that same problem from 1 Hour in Life, which is that I quit the game, come out here, go back in. Now I got to get all the way back to that spot. I remember it was up around the move counter is up around 40 or something, so I got to play all the way back to that spot in the game to see that thing happen. Oh, it's about to happen. Here it is. Oh, it just happened. Well, but so I still had to play up to that spot. Let's say instead I play all the way up to just before that spot. Let's do that. So it was 39, something like that, 36, 38, 39, 40. Okay, we're right before the spot. And now let me quit. Okay, so one of the things I'm doing to get around that problem of 1 Hour in Life, having to play all the way back through the stuff, is to actually be saving full, deep save files that are actually RAM snapshots of all the important volatile RAM that makes up the game state. So this is not just a save file like a JSON file that has a bunch of user configurable save data in it. This is actually a full snapshot of the entire RAM state of the program being saved to disk. And it will come back exactly to that spot right before that laser is about to fire. But we're still kind of in this, I don't have to play through all that stuff over and over again to see the laser, but we're still in this situation where it goes by so fast I don't have time to edit it. So once I got to the point where I was saving this whole RAM state as a save game and being able to kind of hot reload into that exact spot in the game where I wanted to be working or play testing from that point forward, I realized that these RAM states actually don't change that much from frame to frame. Very often there's just a few bytes here and there that are changing, oh, this whole chessboard is part of the RAM state and where all the pieces are and so on. But all that changed on that chessboard state was that rook moving to the side. All that changed on that number counter up there was 1 byte as the number counted up by 1. And so actually from frame to frame to frame, there's very little changing. These RAM states are pretty much static. And so you can actually record the state from frame to frame to frame with very little data just by recording these diffs, saying, hey, from the last frame to this frame, here are the few bytes that changed. like an XOR of what has changed. And then periodically save a full snapshot like every few seconds for jumping between frames more quickly. So you don't have to simulate all those diffs. You can just jump from one, like every 3 seconds you can jump to a spot or something like that. So once we have that in place, let me go ahead and do a fresh run again, where we start from scratch, not loading from that save file anymore. Clear the save file out. Let's quickly go through, and actually we're going to play past the spot where that rook fires. So the rook fires around 41, and then we're going to keep going past it, see the other moves that happen. Eventually the rook, there's going to be a checkmate here. Okay, so there's the checkmate that happened. So because we actually are recording the RAM states and all the diffs in between, we can actually start just rewinding from this spot here. Simulating it all back. The rendering engine is still rendering, but it's rendering based on the changing state here. And of course, it's a little slow to get back to that spot, but we can actually play it faster than normal, skipping frames by simulating 2 diffs in a row. We can also pause and jump around just instantly to any place in the playback by clicking on this jog bar down here. So by scrubbing. And so let's get to that spot that we actually really wanted to see, which is, hey, we're working on this laser. The other cool thing is that if I quit the game right now, don't do a fresh run because I don't want to lose the save file. Whenever you quit paused in the save file, it automatically loads paused into that same spot again. Of course, the first thing I'm going to do is try to center that laser beam, which looks pretty ugly. Let's select all. Let's move it over just 1 pixel at a time just to see when we need it, when we're actually lined up. And we can see that we're still not quite right yet. Let's move it over another pixel. That looks vertically correct. And then we see there's a gap here at the bottom that I'm going to fill in by just grabbing a piece of it, copying it, pasting it. I'm going to do it like that first. Still not enough. And do one more. Let's copy paste some more down here. And that fills the gap. So zooming in, hopefully this shows up in the recording. You see that the laser beam looks perfect now. Yeah, we can also play back really slow around that spot. Oops, let's go back. Where was it? Oh, he hasn't even gone yet. Slow down. There he goes. So you can really play it, slow it down and play it just frame by frame to see everything that happened. So the other thing that's interesting here is we have this explosion happening. I'm going to pause it right there. We can also go in and say, hey, actually we want to edit the particle sprite that's being used for that explosion. Let's make it like a flat looking thing instead of a little box. Save that, and you can see that instantly all those particles. We can make it a star shape. Let's undo that and make it like a star. Or like a little zigzaggy kind of thing. X. Save it. All right, that looks kind of cool. But anyway, so you can do that kind of stuff. Let's back up here again. Let's back up the other way and pause it right there. So this explosion is actually being generated from the sprite in real time. So we can actually come in here and edit this and see how the explosion. Let's cut off one of its heads, for example, and see how the explosion instantly reacts to that, right? Or we could do something interesting like flip this part upside down, edit, flip vertically, and save it. And then it flips upside down. And even the explosion flips upside down. But I said before, we're not just hot reloading assets. We're also hot reloading code. So let's see how that works. So let's get to a good spot here. Let's quit. Instead of just running the game directly from the command line, I'm running it with this script, which is the hot reload script. What it's doing is watching any of the source files for the game to see if they've changed. If they have changed, it instantly kills the game client, quickly recompiles everything with TCC, which takes about 98 milliseconds, then quickly pops up the game client back to the same save spot in the same recording. So if I come in over here to the code, this is the move animation section where we're drawing these lasers. Here's these loops that draw the middle section of the laser. And so for the vertical part, this is going over the rows that the laser spans. So I can come in here and say, actually, I want to skip the top row by just starting at a different index. This isn't as quick as the Tomorrow Corporation demo in terms of like reloading. It takes like a second to actually get the game back up. But that top middle section of the laser's gone. We can also say, actually, there's a glow that's being drawn separately down here. Let's turn the glow off on that top section as well by just skipping it. See that happening. Okay, but anyway, let's turn it back on. And so all I'm doing here, I'm not recompiling inside my editor. I'm just hitting save. And then the script is noticing, hey, that file changed. The other thing we can do here is we have draw reset color happening here. Draw set color and set it to like a nice blue. Actually, let's try green. 0, 255, 0, 255. Yeah, so there's a green laser. Actually, let's make it a green transparent laser. 128. Okay, so there's a green transparent laser that we just made. And we'll see as we get into other spots in the playback, only that vertical laser is affected because of the way that I only edited the vertical part of the code. So horizontal lasers are still the red lasers that they were before, and that green laser is affected like that. So that's how the hot reloading works of code. That's it for the demo for now. Thanks, folks.